Good afternoon, everyone. Anin, bonjour, bonjour. My name is Soren Brothers, and I am the Alan and Helene Schiff Curator of Climate Change at the Royal Ontario Museum. I'd like to begin by acknowledging that the ROM sits on what have been the ancestral lands of the Wendat, the Haudenosaunee Confederacy, and the Anishinaabeg Nation, including the Mississaugas of the Credit First Nation, since time immemorial to today. And I'm really delighted that all of you could join us for today's digital program, which is called The Plastic Age: How Plastics Are Changing Our Planet's Geology, which we hope will inspire you to consider the role of plastics in our environments ahead of the Earth Day on April 22nd. Celebrated globally, Earth Day's goal is to safeguard our planet and fight for a brighter future. The 2024 theme this year is Planet versus Plastic. So for today's digital program, we're going to explore how plastics are becoming part of the museum's geology collections. Today's program features my colleague Veronica DeCecco, who is a mineralogy technician here at ROM. She joined ROM in 2015 and is currently responsible for the analysis and identification of minerals, meteorites, gems, and other inorganic materials. Veronica supervises students in the lab and maintains safety standards in the mineralogy lab as ROM's radiation safety officer. As part of a major ongoing project, Veronica has helped classify over 100 meteorites that are being added to the museum's collections. Thank you for joining us, Veronica.
Thanks for having me. Good to see you. So while normally I look at inorganic things, plastics kind of, in this case, straddle the boundary between inorganics and organics and how we're looking at them as particles. So yeah, this is definitely something a little bit different than what I normally look at, but really interesting in terms of the geology.
Yeah, it's a nice crossover space for both of us. And before we go into the conversation, I just quickly mention to anyone attending that we are going to have time for Q&A at the end. So please, everyone, submit your questions and thoughts via the Q&A feature during the program. And we're going to do our best to address all of them at the end. Yes, so I figured it would be really nice to start by maybe framing also where I'm coming into this whole Anthropocene conversation. And just for those who aren't familiar with the term Anthropocene, that's a big part of kind of what led us to talk about plastic agglomerates today. So as some might know, actually I'm the curator of climate change, but I'm also by training a limnologist, so I study lakes. And the first object in the climate change collection is actually sediment core. So like a plug of mud basically from the bottom of a local lake, Crawford Lake, which was designated as what they call the golden spike of the Anthropocene epoch. So the best place on the planet to talk about or to find evidence of humans having changed the planet. So the Anthropocene, it's a concept, but it is also currently it has been considered as a proposed geological epoch, so supplanting the Holocene, and one that would be defined by the impact of humans on the planet. So saying we have changed global systems and we are no longer in what we have called the Holocene for the last 11,700 years or so. So one of the most important pieces of evidence, people have looked for all of these different elements or things that we're changing with the environment. One of them that people have really pointed to is plastics. And we have plastics all over the world, and we have them in lake sediments. And we can see, where there's a plastic, where there's plastics entering the environment, they're settling in, they're in the air as microplastics. And so this is where you get into this question of geology and plastics, and as Veronica was saying, also like organics and inorganics and really kind of human history on the planet, all being woven together in a really interesting way. With that, Veronica, I wonder if you could start by just telling us what plastic agglomerates are.
Yeah, so if we have that photo of plastic agglomerate, this is a great time to look at it. My amazing, yeah, okay, we're getting it. Anyway, so plastic agglomerate, this is a new term that was defined about 10 years ago. So if we, this photo here. So about 10 years ago, Dr. Patricia Corcoran at Western University, so this is kind of a bit of a local story. So a prof at Western University went to Hawaii with Kelly Jasbach, and they looked at objects that were on the beaches in Hawaii. And they found a bunch of these objects that are kind of accumulations or sedimentations together of plastic materials as well as organic, so things like string and shells and stuff like that, but as well as rock materials, so sedimentary grains. And how these things are forming is people eventually garbage, plastic that's floating around in the ocean, because we've all heard about things like the Great Pacific Garbage Patch. That plastic finds its way on shore or near shore, and some sort of heat-producing event, in this case, beach fires, is melting that plastic. The plastic is cementing all of these grains together and forming crusts, and then solidifying as single objects. So that's why they're called plastiglomerate. It's a bit of a play on the word conglomerate, which is a type of rock that's made up of different types of particles that are cemented together. So it's not technically a rock because it's made of organics, and scientists like to debate a lot about terminology, but it is formed in somewhat similar ways. So we're looking at it in terms of how it can tell us stories about the environment that it formed in.
Thanks. And I remember actually, I think when I first heard of plastiglomerates, even in the news, it was presented as saying, kind of now we know that we have a permanent record because plastics, which are undeniably formed by humans, are now geological. And so
Yeah, so we know that all this plastic is being created, but what was really a question is what's going to happen to it once it's out there in the world. It's been released. We're not recollecting it and remelting it down and reprocessing it. It's everywhere on Earth in some way. So the real question was what was going to happen to it long-term in the rock record. So this is kind of the first evidence of these things creating solid masses, that then the thought is that over time, this plastic is going to become part of the rock record. And the thought experiments we're having is what will it look like 1 million years from now, 2 million years from now, 1 billion years from now, who knows, really, really far into the planet's future. What will this look like as a signal in the Earth's geology? And we don't entirely know yet, although there are some theories.
Yeah, I'm curious. What do you think are the most intriguing theories to you? What
There's
we'll
a couple
see in 1 million years, or
we know that so plastic does sort of break down, but not the same way that other materials break down. It doesn't revert entirely back to its original components. It'll usually break down into tinier particles and release chemicals, things like forever chemicals. So there are a lot of people who are studying the forever chemical side of things. We've heard about microplastics in the news, of these tiny little bits of plastic that are ending up all over the place as plastic breaks down. But these parts that are staying intact as rocks, that allows it to survive for a longer period of time. And eventually, all that sediment is going to end up deeper and deeper in the rock record, because more and more layers of sediment are going to get deposited on top of them, in theory. And then over time, that creates a lot of heat. So we think that with enough heat, there are situations that would be very similar to other fossil creating events that would have happened in Earth's history. So as long as it's buried without oxygen, historically is what you think of for organics. This might be a little bit different for plastics. As long as it's buried, it could maybe fossilize in some way. It could become replaced, where the plastic decomposes into oil products, gases. That signature could get left behind. This could be a future sort of carbon sink, that we're sequestering this carbon deep down into the sediment. But then we could also maybe have things that are like trace fossils. So if you think about things that are like footprints of dinosaurs left behind, or the imprints of leaves, things that are sort of signatures of what could have been there before, but not a fossil object in itself, we might have fossil imprints of plastic water bottles or garbage bags or flip-flops that are appearing in the rock record in the future.
Interesting. And do you think people in 1 million years will recognize that it's a plastic bottle and not like a strange jellyfish, new species of?
Yeah, it'll be an interesting question for sure. And I mean, it also, like, from the anthropogenics, I'm no archaeologist, but like thinking about it, with how much plastic is out there, like, are they going to think this was currency at some point in time? Because like water bottles are everywhere. Clearly they have value in our society.
I'm assuming our currency, like the bills you can't rip that easily, those probably have some plastic in them.
Yeah, those are actually, in Canada, they are a type of plastic. I don't know how they break down. Yeah, that's a good point. It literally is our currency at this point.
Yeah. Well, that's interesting. And then, so I guess, do you think it's fair to say that from a plastiglomerate standpoint, the importance is symbolic more than, say, environmental or anything like that? Like, it's not, thinking about like Earth Day too. It's not the plastiglomerates are a major threat to our health. Is that a
Yeah, I
fair?
think it's a mix of both because the plastics themselves are releasing things like forever chemicals that we know for sure are going to be toxic in terms of what concentrations we don't know, and we don't know how long they last. The plastic glomerate, the object itself is probably not obviously a threat to us. But we also haven't been studying these things, I think, for a long enough period of time to truly know. But yeah, it's not really an imminent threat kind of situation.
But
It's
I,
more
I
of a
guess
slow buildup.
yeah, I mean that makes sense, and I didn't mean to cut you off there, but would you? I mean, I guess the question is, would a plastic be safer if it was not locked up with a rock? You know, if that
Yeah.
plastic's out in the environment, would it have been, you know, is plastic glomerates a way of removing plastics from our environment, or is
Yeah,
it
I mean,
another element of plastics that
it's
we're?
a really good question. I'm not exactly an expert on how this breaks down, but to me, thinking about it, it does remove this plastic from floating around in the ocean and continuing to be mobilized. So that could be, and that's why I thought of it kind of a bit of a carbon sink. But it is definitely a signature of how much garbage and pollution is floating around in our water systems. So it is definitely removing it from being mobilized and moved around, which is a positive. But the fact that it's there in the first place is a negative.
Right. And we did talk a little bit about the geology and you know the Anthropocene. I wonder if there's another geological slide
Yeah.
if we can see. And I wonder if you could walk us through this as well.
Yeah, so we were talking about like the Anthropocene as being this most recent time period that the Earth is going through. But just to put this into perspective of how short of a window of time this is in Earth's history, this is a good analogy for the geologic time scale. So a group of scientists internationally get together and they designate different periods of Earth's history, and we give them all names, and each time period has different signatures that we can look at and kind of like chapters in a book of how we study the Earth. But as a metaphor for how much time has passed on Earth, this is a time scale that is your arm. So if the formation of the Earth happens at your shoulder, going all the way down your arm, humans only appear at the very, very tip of your fingernail. We are a very small blip in Earth's time. The vast majority of Earth's history, there has not been much life on our planet. Single-celled organisms appeared about 1.8 billion years ago, which sounds like a really long time, but the Earth formed 4.56 billion years ago, so a very, very, very long time. And yeah, so Earth has really only had diverse ecology since about the Cambrian explosion, which was.
And I guess,
Yeah.
oh,
No, go ahead.
yeah. So thinking about that fingernail, then. So if we talk about, and that fingernail is probably, I mean, even the Holocene that we're in is probably within a fraction. I mean, the Holocene is 11,000 years. So that's not the entirety of
No,
humanity.
yeah, it's not your full fingernail. It's like the last couple millimeters of your fingernail. It's really, really small.
Right. And then if we were thinking about the Anthropocene, it had a proposed start date of 1950, and that has recently been voted down. But you know, there's still researchers and scientists looking to put forward and keep on discussing this, keeping this question active. You know, imagining a 1950 start date, and that's been proposed based on the enormity of change that's basically happened since the Great Acceleration, since World War II,
And one of
around
those
that
things
time.
being plastics really started to take off during that time period as well.
Exactly. And other Anthropocene markers have been, for instance, plutonium records from the testing of nuclear bombs. So that's
Yeah.
all around the world as well. So do you think, though, again, kind of looking, you know, from geological timescales, I mean, we talked about how you could look back a million years from now. Even that would just be another probably millimeter on this time scale, right?
Yeah. So it really it depends on how things change as well. So like one of the time period changes is the asteroid impact that is credited with killing the dinosaurs. And we can see, even though this was probably a very brief event, it was such a large sudden event that we can see the signature for this over the entire scale of the Earth. Because there's a sediment record that contains an increased level of the element iridium. We can find that iridium layer throughout the Earth and throughout the Earth's rocks. Plastic is also going to be present in a single layer throughout Earth's history. While we think an asteroid impact was probably a lot faster than the last 70 years, 70 years in the Earth's history is pretty short. That is kind of a blink of an eye for the Earth. So far we're at a point where this is going to be a very thin band of Earth's geologic record. But it really is going to depend whether or not we keep depositing plastic.
Right, and see what it represents again as a change. If it's a piece of evidence that's coincident with all of these other things, or contemporary with all of these other things that are changing, and carbon cycling changes and climate change and all that, that's really that's where it gets important. And I guess that's another question with microplastics. I mean, what is the I wonder actually if you feel comfortable quickly sort of giving a definition of microplastics as well, because I think we've mentioned it but didn't actually explain what it was.
Yeah, so they're just like plastic particles that are broken down. So micro meaning usually you need a microscope to see them. They're very, very small. It's a particle scale size. So plastics generally start off larger. They can be released from the breakdown of processes. Even things like washing your clothes can release plastic particles from your clothing, because a lot of our clothes are made out of synthetic fibers. Or the mechanical breakdown of plastic objects that are being built. I think tires are one of the major producers of microplastics. And microplastics have been found everywhere all over the earth. There's some crazy statistics, like they've been found in human blood, and like I think you were talking the other day about the Arctic. They were found in snowpack and the Antarctic as well. They've been found everywhere on the earth, and even in the most places where we thought were the most remote. So we know that signature has definitely made it around the globe, and people weren't really as aware of it until relatively recently as well.
And do microplastics form plastic conglomerates as well?
I don't think the risk is as big in that case. We're mainly looking at macroplastics, but some of those particles, when they're accumulated together, in some of these papers, they refer to them as confetti. That confetti, still tiny, but you can still see with your eye, it is re-glued together.
And then do you have a sense of...
I also want to make sure that I do shout out Patricia Corcoran for donating the plastic agglomerates to the ROM in the first place. So we were able to have these samples in our collection for us to be able to use them for events like this, because they were donated to us. So definitely big thanks to that team for bringing them to us too.
Nice, that's awesome. And yeah, I saw that actually one question has come through, so maybe I'll just jump to that quickly to make sure we get to it. From Doug Gibson, we know that we are leaving recognizable amounts of concrete in the geologic record. What kind of amounts of plastic agglomerates compared to concrete?
Hi, Doug. Doug's a big fan, and if anybody is interested in joining the Friends of Earth and Space, Doug is the person to get in contact with, just as to promote the Friends of Earth and Space. But so far, plastic agglomerates have not been found in that many places in the world. We've only found them so far. The last paper I read was 11 countries on five continents. So that's almost every continent. They haven't found them in Australia yet. They haven't found them in Antarctica yet. But generally, we're looking at places where there is seashore, where plastic is floating up onto the shore of some kind, and then there is a heating or melting event. So that melting event is people starting fires or wildfires. There is some evidence that lava flows cause them, but also that lava flow, if it's hot enough, will cause the plastics to just melt and evaporate. So it has to be hot, but not too hot. Yeah, so not a ton of formation mechanisms to do yet, whereas we have coated a lot of things in concrete. There is a lot of concrete out there. But then also, if you think about concrete the same way, humans have made concrete. Concrete can be broken down into chunks. Those chunks can survive and then be resedimented through deposition. And then the word for when a rock turns from grains, or when sediment turns from grains into a rock, is called diagenesis. It's like the heat slowly transforms and sediments things into a rock. So if we take little bits of mushed up concrete that never fully breaks down, we can also eventually create new types of rocks. So it's not just plastics that are eventually going to create new types of rocks. Things like asphalt, all the bricks that are lying on beaches, these things are slowly going to become new rocks one day. It's just plastic, I think, is much more mobile. When you heat it, it creates kind of a glue. So we're starting to see it in these things first.
Awesome. And to follow up on that, Mr. Hancock has asked, can you explain what forever chemicals are? Thank you for bringing that up. It was something we'd mentioned.
Yeah, so the best people to look up about forever chemicals is Miriam Diamond at the University of Toronto. She does a lot of work on forever chemicals. The idea is that these are chemicals that last a really long time in the environment. I I don't know the time scale relatively that it's estimated they break down on, but they last a very long time and they can have detrimental effects on ecology. And they're used in many products that we use in our everyday lives, and also through the breakdown of products that we use in our everyday lives. I don't know if you have anything to add to that, Soren.
Yeah, well, I think, I mean, again, it's a little bit out of my own sort of specific field, but from what I understand as well, one of the issues, for instance, with microplastics isn't that they're not creating, like the microplastic, a particle in itself can be inert, but it's really good at holding on to, like absorbing these chemicals. And that's where it becomes sort of like a mode of transport for these forever chemicals or these long-lasting, like legacy contaminants through an environment. So it's like a mode of transport rather than, but I believe in most cases it also gets it from the environment. So these are things that they can kind of concentrate through whatever the microplastics are doing. Do you know if that's fair? Yeah.
Yeah, that's fair. And then also with the forever chemicals themselves, I know that there are risks of many of them causing increased cancer rates and early death, mortality of creatures in the environments that they're living in. But yeah.
Great, thank you. And also, Mr. Hancock, how can we help clean up the microplastics?
That is a great question. I don't have an answer to that question. So I know there's a lab group at the University of Toronto that's looking into this, Chelsea Rockman's lab. So they are studying plastics and microplastics in the Great Lakes as well as other water bodies and trying to identify them for future cleanup methods. It's a tough question because if you filter out the tiny particles of plastic, how do you make sure you're not filtering out tiny particles of living things that are helpful to the ecosystem that they're living in? As a limnologist, do you have anything for that, Soren?
Yeah, it's definitely, I mean, I guess there's two sides of it in terms of solving the issue, like the broader part of solving issues. One part is just looking at supply, and the other part is looking at like the removal, cleanup. And so I know with cleanup, I've read at least there's some articles out there that talk about Newston, which is, I don't know if you've heard of Newston. It's the whole sort of planktonic, or well, I guess plankton are free floating in a water body. Newston are organisms that live on the surface of a water body. So you can think of kind of like water striders. But Newston will often be impacted, and they're one of the least understood sort of biome or ecosystem ecological groups, say of the open ocean. But if you're having these huge sort of plastic cleanup programs that often just skim huge surface areas of the ocean, that would directly impact Newston, and that have carbon cycling impacts and ecological and biodiversity impacts on the ocean. So there is this kind of open question, and some of these communities have started to live or find ways of living with the plastic that's there. So, some biologists, and especially working, say, in the marine biology field, have raised this question, like, where does our ecological concern, where does what we understand of the system end in terms of how much we want to destroy one ecosystem trying to save another? And one of the issues with birds and microplastics is, like seabirds feeding them to their babies. So you have things that are eating these microplastics, and that's killing seabirds. And so there's definitely an ecological issue with leaving them, but there could be other ecological issues with removing them. I think I get the sense that most of the conversation is really shifting to how do we stop plastics from entering the ocean. I mean, that's obviously one of the big places. And that comes down to, I know I've spoken with Chelsea Rockman, Dr. Rockman at U of T, and I think one of the first things she always points to is that despite all of the problems with the recycling systems we have, they're still really important. We need to get better at recycling and reducing the purchase of plastics, getting more out of this habit of just having to, have everything singularly shrink wrapped, and this kind of single-use plastics is really problematic. So
and it's regardless of where the plastic comes from as well. Like if it's a bioplastic, it's still the same type of material. So that was a push for a while, is to switch from, like, oil and gas is awful for many other reasons, but that also necessarily isn't better if we use bioplastics as well. It really comes down to recycling and preventing it from entering the ecosystem in the first place.
Yeah, absolutely. And And I know actually Doug Gibson and I have spoken about this before too, but I think there was an industry convention in the 80s where there was like a plastics industry convention where one of the talks was called, the future of plastics is in the garbage. And it was actually like it was a conscious move to try and make, flood the system with basically single-use plastics as a way of generating more money for the industry. So I think it's worth recognizing we don't actually have to have this kind of system where everything is just supposed to be used and tossed like once shrink wrap something. This is very much kind of a conscious move for an industry. So
Yeah. Yeah, and there are also there's more in-depth recycling systems. So I mean, here everything ends up paper, plastic, metal, all ends up in the same bin. And then we're relying on it being sorted further down the line. There are other systems in other, like Japan, for an example, is kind of famous for having increased recycling measures. But there's some small towns that you take everything to a recycling depot and you sort it yourself into something like 23 different categories of stuff. And that increases the likelihood that it will get recycled. Because one of the major issues with plastic is when you buy a single object, it isn't necessarily made out of one type of plastic. So if you want to recycle it or reuse those materials, you have to be able to identify what it is in the first place. And it also adds that extra layer of corporations having to make things more recyclable from the first place when they're building them.
Yeah, and I've even heard some people say that I think the term recycling is actually sort of inappropriate when used in plastics because it technically should be the ability to make something of equal sort of constitution with the same materials. So say like you can recycle a tin can or aluminum can because you can create another aluminum can specifically from it. But with plastics, once you try and recycle it, you're downgrading to a different sort of level of plastic every time you do that. So you can't just make, plastic a certain kind of plastic box from another certain kind of plastic box. And I've also heard that there was an industry push, I think, to have that little recycling logo on all plastics. Originally, that was intended only for ones that you could recycle, but then there was a push to say, oh no, let's have it on everything to give consumers the illusion in a way that they can recycle and then just put little numbers inside. And even if it was known that there's only one type or a couple types that could be recycled, they wanted to.
Makes you feel a little better.
Yeah, and then you
end up in the city of Toronto, you can't recycle any black plastic.
Right, exactly. Yeah, so it is. I think it's a good conversation to be happening right now. Okay, there's a couple great questions. Gail Greer has asked that the term Anthropocene has become widespread. Do you think that the geologists will still use it to name an epoch, even if not dated to 1950?
So scientists really like to argue about terminology, and I think this does fall in. We are going to continue to argue whether or not the Anthropocene exists for, I think, a while to come, unfortunately. I think regardless of whether or not it's accepted, it is a useful way to describe that humans are having an impact on the geology and ecosystems that we see all around us. It sums up all of those issues in one word, which is very convenient. But how do you feel about that, Soren?
Yeah, and I think I would add that, the question was about whether geologists will use it. I think also it's good to recognize that many people across the social sciences and other fields of science will continue to use it sort of beyond. It's definitely not just at this point a geological term. And I've actually been in conversations with other academics who were been in several conversations with other academics who sort of even fight amongst themselves whether it matters what geologists think. And some say, well, the fact that we have seen on there means that it is a geological definition. If they don't accept it, that means that we shouldn't use it. Others say, it has its own, on some levels it has its own baggage, but it also has its own uses in say, like a lot of social science fields and also environmental sciences and thinking about what we've done, and I'm really interested in thinking about all of these different measures of what the Anthropocene, how it's defined, and which of those we can sort of recover from. If we think about climate change, which we can't recover from, think of like mass extinctions. I know some people don't like any words that start with it's like we can't return to what we were. It's always moving forward and there's no going back. But I think, yeah, whether we call it Anthropocene or not, maybe it's probably not going to change anytime soon just because it's such a commonly used term now. Carolyn Duncanson, I've heard about filters for washing machines. Have you heard about filters for sewers that would screen out microplastics from the whole system?
I haven't actually. I would assume that people are looking into that. But no, it's not something I'm familiar with. I also am more familiar with washing machines being the major place where household use is trying to filter them out. I'm not sure what municipalities do on a larger scale. Do you come across anything like that?
So I haven't seen filters for, yeah, at that scale. I have seen a lot of things coming up that focus, for instance, more on macroplastics than microplastics, but say at the river, like intercepting them in rivers before they reach.
Kind of like those floating machines that are like
Yeah,
skimming.
I've seen a bunch of different ones. I mean, actually, one of the, and I can't remember where it was. It may have been in the Netherlands or Denmark, where they had even a series of bubbles that were sort of diagonally aligned under a river or a canal before it hit the ocean, where it kind of, this like line of bubbles actually brought all of the surface floating plastics to the side of it and then collected them there. But it was a way so that fish and other kind of organisms could just swim up and down past the bubbles and things that were, but microplastics or at least macroplastics were there. And I would add, actually, I know, and I worked with an ecotoxicologist at University of Guelph some years ago, who I think still feels that macroplastics are almost sometimes looked over as such as an important ecological issue. Perhaps more so. I mean, people talk about microplastics a lot right now because it's such a new thing, but we shouldn't forget that macroplastics are a huge issue. I mean, those are ones that are, for instance, killing albatross babies and things like that, or
Well, being
these
found in like
seabirds.
whale stomachs full of plastic bags and
Exactly.
stuff like that.
So stopping those from going to the ocean and things like that are really important too.
Yeah.
Madame Henri from Valleyfield says, grade 4 students learn about the rock cycle. How do you think this inclusion of microplastics in rocks will affect the rock cycle?
So that's an interesting question. So the rock cycle, all rocks can be summarized into one of three major buckets. So they're either sedimentary, forming from sediment, igneous, usually forming from molten rock of some kind. So if you think of like lava, volcano flows, stuff like that, or metamorphic. So rocks that have been heated and squeezed so that they start to recrystallize and have different textures. So plastiglomerates are a type of sedimentary rock, sort of. They're not technically a rock is the issue, because the way we define things, and geologists care so much about how we define words, is that if it is anthropogenic, if it is made by people in any way, it's not technically a rock. So in terms of a teaching perspective, if you wanted to include it in conversations about how rocks form, it would fit best in a sedimentary unit, because we're talking about particles that are cementing together, especially in places like ocean shore and shoreline deposits. But they also fit well into a geography component because we're talking about that human impact, the human geography aspect. So technically not a rock. The reason why we have them in the collection, we have it in the geology collection, is because it's that signal of how our Earth's processes are changing or being impacted by people. But it is a different type of sample, different example of an object than if I were to pick up a sandstone that was formed 65 million years ago.
Awesome. Thank you, Veronica. And we've gone past our half hour of our program, but this was a really exciting conversation. And I think I learned a lot today. So thank you, Veronica, and thank you everyone for joining us today and for sharing this really interesting piece of the museum's collection. A broad reminder that Earth Day is celebrated internationally on April 22nd. And thank you to everyone for spending part of your day with us. And I hope you have a good rest of your afternoon.
Thanks for having me. Good seeing you.
Good to see you.